We are drowning in AI-generated text, from emails to essays, code to creative writing. Large language models are churning out billions of words a day. And for the last few years, we have been asking the same question. How do we know what's real? You've probably tried those AI detectors. You paste in a paragraph and it flips a coin. Sometimes it says your own writing is AI. Sometimes it lets a bot pass as a human. It's a mess. The problem is, most detection is post hoc. It tries to guess based upon style or statistics after the text is already written. But what if the model could sign its work? What if there was a hidden fingerprint inside the very choices that the AI makes? Invisible to you, but blindingly obvious to a computer. Something like this, where for you the visible message says A, but there's a hidden watermark that's only visible to the machine. We can see this as I drag this thing around. This is the promise of SynthID. SynthID is a new technology. It's been around for a year or so now by DeepMind, where they are trying to figure out how do we add watermarking inside the AI-generated text. And it's not only for text, it's also for audio, images, and videos themselves. So the goal is to figure out how do we classify and first of all tag all the content that is being generated, and then later being able to also analyze it and give you an answer whether this was generated by an LLM or not. So how does this work? This is the promise of SynthID text, a new watermarking scheme from Google DeepMind that was published in Nature. And unlike the tools before it, this isn't just a theory. It's been running live in production on millions of Google queries, Gemini queries, right under our noses. Today we are going to open it up and exactly see how it works off. Watermarking text without breaking the model quality. So first, to understand this, we have to remember how LLMs think. They don't really know anything. They are essentially next word predictor. So next token gets predicted. It's a probability machine. When it writes a sentence like my favorite tropical fruit is, it calculates the probability for every next move. So we can try out here, we can try out new sample token, and generally it's going to be mostly mango because mango has the highest probability in here, but it could differ between these 4 variations as well. So maybe mango is 50%, lychee is 30%, durian is 5%, and as I'm trying to predict the next token, it will oscillate between these two. Normally, the model rolls a die and picks a word based upon these odds. This randomness is what makes the AI creative. If it always picked the top word, it would sound robotic and repetitive. So now, how do we watermark something that is inherently a little bit random? So this is where the existing methods, which are red versus green lists, come in. What we do is we start with model is forced to pick from a green list. Vocabulary is randomly split. And this split causes issues. Let's see how it works first. So you can randomly split the text, and when the model is generating, it will pick from that new random split. So I'm clicking the button, it's generating random splits, but the random splits are same. But this time it generated a new random split where my favorite fruit is durian. So the quality actually degraded. This is not factual information, but the quality itself degraded because generally the most probability in here is mango. And this happened because the model was forced to pick from the green list. This degrades the model quality output quality. So it works for sure, of course. You can see the paragraph, but it does not. It destroys the quality of the model. So, and the reason was because it had to pick from the green list in here. So this is where the DeepMind paper changed the game. They introduced a technique called tournament sampling. The tournament sampling, instead of banning the words, it holds a competition. So it holds like multiple stages of the competition. So in this example, we have the first competition where we add essentially a secret key in here. So let's say we had 4 possibilities: mango, lychee, papaya, and durian. It runs a tournament. It pairs up mango and papaya in this case. Whoever wins gets to the next level, and we do it again. And what is happening is we have this secret key in here. This secret key is a nudging score in here. This nudges and acts as a tiebreaker in case of similar possibilities in here. And thus, rather than banning certain words, it generates more cohesive score or cohesive outputs. So let's just change the secret key, and you will see the output changes as we change the secret key. But in this case, we haven't prevented the model from picking any of the possible options in here. We just changed the randomness in here and control the randomness a little bit. So this happens over and over again. Like there's only 4 options in here, so it's like fairly simple. But there's gonna be multiple, like hundreds of variations of possible options in here, and then we get to the answer. The crucial point in here is this tournament is rigged, not only statistically because of how these probabilities in here stack up, but also with the secret key. It nudges the winner towards a specific choice, and that choice essentially ends up becoming the watermark. So why do we go through all this trouble? The trouble we go through is because this sampling achieves something called as non-distortionary, which essentially means that we cannot tell the difference between the watermarked and unwatermarked text. So to do this, the paper, we will have some references at the end. The paper went through 20 million queries that they analyzed and looked at the thumbs up, thumbs down delta between when users gave a thumbs up, thumbs down of like on the output. They found out that it was actually very insignificant, 0.01%. So it's statistically indistinguishable for the end users. Users can't tell whether something was watermarked or not. Now, to detect it, how does the detection work? On detection, we take the same key. We look at the words in the text and we run it against, we go with essentially the query here is, if we ran the tournament again with our secret key, would these words would have won? Like, would the words be in the same order? If the answer is yes, way more often than random chance, then it's watermarked. You don't have to do it. You don't do it at the one complete level. You break down the whole output into small chunks, and you see for each token what is the predictability. And if it matches more often than not, we say that it is like if the signal is too weak, we can't say that. Like in case of examples like this, the capital of Paris is France. There's only one valid choice. You can't really make a lot of other choices in here. So in this example, we can't detect. But if there's many choices, something like creative writing, we have a lot of strength in the watermark, and thus we can detect it much easily. It's not magic. The paper is very honest about the limitation. As we just talked about the entropy in here, if the option is only a very few options in here where there's only one right answer to the question, there's not going to be, we won't be able to detect if it's watermarked or not. So this works for short answers or very factual answers as well. The second is you can take the watermark text, let's say something that got watermarked, then you convert it or pass it to another AI to paraphrase it, and then you might ask it to do a language conversion. You convert it into French, and then do another conversion, convert it back into English. Now, through that, let's say we start at 90%, the quality will start degrading and degrading, and when the strength is not good enough that the model can give you with high confidence that it has detected something, it will fall back to not saying it correctly or not detecting it correctly. So the significant rewriting washes away the signal. But this is the cool part here, that Google is not keeping this for themselves. They are trying to make it available for everybody else. The open source repository for SynthID, this is a reference implementation. It's available open source. People can try it out on their own. And then just to clarify, it's not a silver bullet. It won't catch everything. They are also working not only on text, they are working on image as well. So on image, if you are not familiar, you should take a look at some of the LinkedIn feed. I posted this video yesterday about Nano Banana launched, and I generated this image with Nano Banana. And this is content credentials, where the image metadata itself had all these different details. Image has EXIF metadata that was signed by Google in here when the image was generated. So at this point, this image is known to be an AI generated image, as the label is saying in here, because the image itself contained the EXIF metadata. But you could take a screenshot of this. You could pass it through a few filters. You could take the original image, pass it through a program that splits out or removes all the EXIF metadata, and then you won't be able to figure out if the image was generated by an AI or not. So metadata acts like a digital sticker. This is the sticker. You can remove that. It's good. It provides a rich audit trail, but it's extrinsic to the content, where it's not within the content. It's an attachment kind of thing. So if you let's simulate an attack in here. So it strips of the metadata from there, and then now it's unverifiable. But SynthID, the way it works is since we embed the details directly into the content, uh, when when somebody takes a screenshot or regenerates it or passes a small filter on it, we can still detect it in the pixels in here. So this is what's happening right now. There is a SynthID. This is what was happening so far. There's recently SynthID detector that DeepMind team is working on making it available, and there's a join wait list here. You should join it, and then it will work on image, video, audio, and text. This is just a demo implementation. It doesn't actually work in here, but yeah, SynthID detector would be amazing because it would be able to give you an answer on whether something was generated by Google's AI or not. So just to clarify, this does not work across all the other models because the tech is right now specific to Gemini models. I hope this is something that can be made available to everybody else as well. This whole thing was actually generated using some of the content from the Nature paper that's available here, from the open source repo, which is available here, as well as the overview on the DeepMind website, which is here. This was generated on Gemini 3 build mode, which is amazing. You can see the whole website. I generated this over a few prompts in a few hours. This is amazing, and if I get chance, I will share the link as well. Anyway, you should go check it out. Check out the Nature paper. Check out the website. Join the waitlist, and hopefully this helps you get some deeper understanding. This video helped you get some deeper understanding of how SynthID works and how this problem is being worked upon in the industry, and hopefully you can use something like this to detect if the submissions from your students are coming from AI or specifically Google AI or not. All right, until next time, see ya.